This is sections 3.4 and 3.5. This is part 2. We have just talked about some formulas, and I've written them on the note card, so again, I can just drop them down when we need them. Slope is from the previous section. We did slope-intercept form last time as well, but we have it again. So here's a slope-intercept, point slope, and standard form. When you go to learn these, I strongly suggest that you learn the name of the formula along with the formula because it tells you what it is it's used for. This says slope-intercept, that means I need a slope and I need an intercept. Point slope, any point and a slope. Okay? So these first questions, write the equation of the line that meets the conditions. Give the answer in slope-intercept form. Okay? That means whatever I do here, I'm going to end up rearranging things so it matches this pattern. Okay, so let's look at what we have. We are given a slope, and we are given the y-intercept. I'm going to work this one two ways. If you notice that you have a y-intercept, then you can plug directly into here. You might not notice that you have a y-intercept. It might not say it, and you might just look at this and say, okay, well, I have a point. And then you would use this formula. It doesn't matter. It works either way. So let's look at the slope-intercept form. This is my slope, and this right here is b. So your b value is 4/5. So if I plug directly into y equals mx plus b, it's y equal to, my m is negative 2/3, x plus my b value is 4/5. And this is the answer. And that's great when you are given a y-intercept, but real life that doesn't happen that often. So let me work this one using the point slope formula as well. Okay, so in that case, I'm going to rewrite some of this. My m is negative 2/3. The point I am given is 0/4. So this is what you would do if you did not recognize that this happens to be your y-intercept. This would be my x1, this is my y1. Okay, so let's plug into the formula. Y minus y1, regular y minus y1, my y1 is 4/5, is equal to my slope, negative 2/3, times x, regular x is part of my answer, minus x1, and x1 is 0. It's kind of ugly. We will always be simplifying here. What I'm going to do here is, of course, x minus 0 is just x. But if this were some other number, then I would distribute the fraction. But simplifying a little bit on the right-hand side, I have negative 2/3 x because the minus 0 is that, well, that's just x. Okay. Now I want to end up in y equals mx plus b form. I've got y, I have my mx. Now I need to move this over to get the y alone. Don't really worry about dealing with a fraction here because you're not going to be able to combine it with anything because it doesn't have an x. So you don't really have any arithmetic to do. You just need to recognize that it gets moved over. So I get y equals negative 2/3 x plus 4/5, which is precisely the same thing I got here. Okay? So if you recognize it, great, it's quick. If you don't recognize it, that's fine, it will still work. Let's do this one as well. And we are given the y-intercept, so it's a gift. We can use slope-intercept form because we are given every piece we need. So this is y equals m, which is negative 3/4, x plus your b value is right here, so 7. So the answer to this problem is y equals negative 3/4 x plus 7. Now maybe to you it feels like we're not done, like we haven't solved for anything. We're not being asked to solve for things. We're asked to find an equation that fits the information we are given. Now why might you want to do that? Well, businesses, for example, they end up with all kinds of data points and they want to be able to make predictions based off the data. That's where this comes in. If you have the data and you can create an equation for it, then you can use the equation to make predictions in the future. Okay, that's just one reason why you might want to do this.